Good morning to all of you. Today we are here to study the water quality, that is the characteristics of water, that a very important and initial topic, crucial yet of environmental engineering, not only for academic purpose, however, for the gate examination and multiple competitive examination, this is a very important topic. Here we are going to see the three different qualities of water characteristics, that is physical, chemical and biological. In the first video, that is in this video specifically, we are going to discuss about the physical characteristics, that are temperature, turbidity, etc. Temperature is the measure of heat energy, and normally the temperature of water varies between 10 to 20 degrees centigrade for specifically for the drinking of potable water. However, as the temperature increases in the warm conditions, the temperature of the water may rise to 30 to 40 degrees centigrade, but this rise is not beneficial or good for us as it promotes the growth of microorganisms. Hence, it is very much essential to make sure that we have a temperature range between 10 to 20 degrees centigrade. Otherwise, the increase in temperature may also lead to decrease in the oxygen level. Also, we have observed that temperature is very crucial for chemical reactions, as almost all the chemical and biological reactions taking place within the system is temperature dependent. So, variation in temperature may affect the chemical reactions adversely. In addition to this, the temperature decrease will lead to the increase in viscosity, which will affect the settling of solids in the upcoming treatment system. Then the instrument that we use to measure the temperature is thermometer. Second physical characteristics is color. However, it is beneficial or observant that water should be colorless, as it does not affect the health reasons if color is present in the water. However, aesthetically the water is considered as impure if we find a colored substance in the water. The material decayed from the vegetation, inorganic matters are the few components that impart color to the water. There are two types of colors present in the water. One can be the apparent color, other is the true color. Apparent color is the one which is caused by the suspended solids. Similarly, true color is the one that is caused by the dissolved solids. Filtration can be used to remove the apparent color. However, for the removal of true color, various other methods have to be incorporated. Color is measured in platinum cobalt scale with the help of tintometer, and the reading that we get is TCU, that is true color unit. Now the question arises is, what do we mean by true color unit? So a true color unit is when 1 milligram of cobalt platinum is mixed in 1 liter of distilled water. The color imparted by the mixing of the two gives us the one standard unit of color, that is 1 TCU. For drinking water standards, the TCU may range from 5 to 20. It is not acceptable to have more than 20 TCU for drinking water. Next physical parameter is turbidity. Turbidity is the measure of resistance that is offered by the particles present in the water sample according to the passages of light. So we can say that the opaqueness in water can be in layman language known as turbidity. The higher the opaque surface, the more is the turbidity. Turbidity is a surface phenomena. Large amount of suspended matters such as clay, silt, fine particles such as organic materials present in the water may result in turbidity or muddy appearance of the water. The measure of extent of which the suspended matter is present in the water is either observed or measured by the absorbance of the scattering property of light. There are various methods or instruments that are used for determination of turbidity. Turbidity is caused by suspended and colloidal particles. Suspended particles and colloidal particles are the major sources. However, as we have seen that for color we have cobalt scale, similarly for turbidity units, it is measured in silica scale. As we have defined a TCU, that is true color unit, similarly turbidity unit can also be defined as when it is the amount of turbidity generated when 1 milligram of finely divided silica is mixed with 1 liter of distilled water, which can also be known as Jackson turbidity unit. For drinking water purpose, the turbidity is in the range of 5 to 10 TU. Turbidity is measured as turbidity rods or turbidity meters. Turbidity rods are normally used in the ancient days and specifically for the turbidity greater than 25 TU. But this limitation is not with the turbidity meters. Turbidity meters work on the principle of measuring the interference caused by the water sample to the passage of light. Turbidity meters are like Jackson turbidity meter, Baylis turbidity meter, and nephelometers. As from the image, we can observe that the clearer the water, the lower will be the turbidity. Or we can say that the lesser the amount of solids, specifically suspended solids and colloidal solids, lesser will be the turbidity and higher will be the light scattering property from that water. Nephelometer. Here we are discussing about nephelometer in a little detail because this is the instrument that is normally used in any of the academic or the laboratories of national importance. This nephelometer is work on the principle of light scattering, which is referred to as FTU or NTU, that is Formazan turbidity unit or the nephelometric turbidity unit. It measures the ratio of 90% scattered light to the transmitted light at 90 degrees centigrade. So 1 NTU is 1 milligram of Formazan polymer when mixed with 1 liter of distilled water. The turbidity produced can be said as 1 FTU or 1 NTU. Here we have the image of turbidity meter and lower we have the principle how the turbidity meter works. The next parameter that we are discussing is the taste and odor. Similarly, as we have seen for other parameters like color, taste and odor should also not be present in the drinking water sample as it affects our taste buds and the olfactory nerves. There should be no noticeable taste at the point of use of any source of drinking water. May it be a ground source, may it be a surface source. Ground sources can be water from river, water from lake, ponds, etc. However, groundwater sources are like the water from tube wells, bore wells, wells, or borings. Normally, the dissolved organic material or the inorganic salts present in the sample may impart taste and odor. The presence of dissolved gases also impart odor such as H2S, methane, carbon dioxide, etc. Normally, fresh water is odorless and it does not have any odor. However, when the water is stagnant or stale, then it converts to the wastewater which has an objectionable odors. So the numerical value of taste and odor can be quantitatively determined in the laboratory. It is a very simple method in which we have to take a known volume of the sample for which we have to determine the threshold odor number or threshold taste number. Let's say it be a volume V1 of sample A. Similarly, we have to take a known volume of distilled water used for dilution. The dilution has to be done in the given sample up to the point where we have no noticeable taste or odor. So in that case, the TON or TTN can be calculated as the total volume, that is volume of sample that we have tested, plus the volume of distilled water used for dilution divided by the actual volume of sample taken. The unit of taste and odor is then expressed in the threshold numbers. Specific conductivity. Specific conductivity is also one of the physical parameters, as specific or electrical conductivity of water is a measure of water's ability to conduct electricity. As we all know, pure water is a poor conductor of electricity. The only reason behind this is as the pure water does not have any dissolved solids. So conductivity is the presence of dissolved solids or salt in the water sample. In general, it gives the measure of number of ions present in the water sample. The element that contribute to the electrical conductivities are calcium, magnesium, potassium, bicarbonate, sulfate, chlorides, etc. The electrical conductivity is measured by the conductivity sensors, and it is measured in the unit known as Siemens at 25 degrees centigrade. As the temperature increases, the conductivity also increases. So here we can mention that all the physical or the chemical or biological properties that we are going to see are all interrelated. So any change in one of the physical or any other property will lead to the change in another properties. Thank you.